Yeah, this class is okay for that.
Okay.
Statistics is really the math and statistics is not that challenging in terms of like it's not like all this algebra that you need to know. The problem with statistics is that's a lot of word problems, so that's like inherently difficult for people just to start. So and then business math, um, you should be okay. I mean, I'm not going to say it's super easy, but you should be okay. Anyone else?
Just
No?
So I'm an art major. This is the right class for me, right?
Yes.
Okay, cool.
Yeah, yeah, because this will get your math out of the way
Okay,
and you won't have to suffer. That's
sweet.
fine. Yeah.
Thank you.
Okay. Okay, so we have our, this is, you know, the outcomes, blah, 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 then the evaluation, which is just saying that we have a standard grading scale. This is a college level course, so there's no like weird grades that we have in developmental courses. This is A, B, C, D, F. That's it. That's the only grade you can earn, the only grades you can earn. Although there is, as of this summer, a special grade for military. Anyone who's military or I guess former military, if you don't pass the class, there's a special grade. It's called an incomplete military or something like that. I don't know. So if you are military and you don't get through this class, you can get an incomplete instead of an F. And I'm not quite sure how that all factors into GPA and stuff, but it's a brand new grade. I don't know a lot about it. So if you have any questions about that, give me some time to do some research, but just like send me an email and be like, hey, what's that grade about? I don't think anyone's going to ask me about it until the end of the semester if they're not passing. Traditionally, like in a normal summer class, face to face, my success rate in this class is like everybody. Like the only people who don't pass are the people who like drop out because they've got personal issues or work can't balance life out. I mean, really, if you show up, you do your homework, my exams are not going to be like some shocking surprise to you. Everything's going to look familiar. It really is just trying to get you through this so that you can move on and do art or business or whatever it is, and still succeed in college.
So if we haven't done algebra in years,
Well,
is it something that's gonna be hard? You know what I mean?
I don't know. It's going to depend. Like everyone's different, you know.
Yeah.
I'm going to try as much as I can to kind of help you, but you know, believe it or not, at Northwest Vista College, let's see, we'll take a little poll here, just a verbal poll. If you take all the students who come in Northwest Vista College on a standard semester, what grade level of math do you think the average student comes in at? Anyone want to guess?
like freshman high school.
Freshman high school? Anyone else?
Maybe less.
Sophomore, junior, high school.
Try fifth grade.
Wow.
Fifth grade. So the reality is that our public school system is not really preparing students for college level math. So if you're concerned that your math skills are weak, you're with a lot of the students. I mean, that's just the way it is. I mean, I know a lot of students get through high school and they get through maybe algebra in high school, but you know, it's different. It's, you know, it's a very different animal in high school than it is here. There's no makeup tests here. There's no, you know, you get partial credit on exams, but there's no, it's not just show up and pass, which in high school we see a lot of that. And so, you know, everyone's going to have deficiencies. They're going to be weak at something. The things that I assume that you can do right now is I expect that you can like multiply, add, subtract, all the little things that we're going to learn. You know, I will kind of present it in the sense that you haven't seen it recently, and maybe you need to refresh on it. For some of you, this class is going to be hard, and for some of you, this class is going to be so easy, it's going to be hard to stay, motivated, which I apologize, but that's the way it is. So we're teaching at one level here, one speed, and that's kind of what we're going to do. So if you're struggling, I think you need to reach out to me, take advantage of, office hours. Let's identify what your weaknesses are, and then from there, I can try and help you, Lorenzo, does that kind of,
Yeah.
you
Yeah.
feel a little bit better? I mean, it's
Yeah.
been a while. Okay.
Yeah.
All right, so the grade breakdown, you know what? Okay, so here's the thing that's I highlighted there. Normally I give a grade for homework, okay? But there's really no way for me to collect your homework easily. So your entire grade is just gonna be exams. And each exam is gonna be equally weighted, 20%. And the way that I plan on doing exams, I already told you, you're going to come in here and you're going to show me your room, and then you're going to take the test just like this. I'm just going to sit here and watch everyone. And then what you'll have to do, and we'll work on this, don't worry about it right now, but what you're going to have to do is as soon as you're done with your test, within about 10 to 15 minutes, you have to get your handwritten work to me. So that's got to be emailed to me, or actually we're going to use Dropbox. So you're going to have to scan your work using a scanner, or you're going to have to take pictures with your phone of each page and then figure out a way to convert those photos into a single PDF file. Like I said, I will go through this. We'll practice with this. So by the time we get to the exam, we will have all tried it a little bit. So I'm going to take that handwritten work and then I'm going to grade it. And so I'll be looking for partial credit. Did you have the basic idea? And so each exam, 20%. And there won't, like I said, there won't be makeups, but I will see how the class does. If the whole class struggles, then maybe that exam, wasn't a good exam. I don't know. We'll see.
So that means that us doing the work is part of the grade?
Oh yeah. Mm-hmm. Yep, you have to have work. It can't just be an answer. Sorry, Dalton. Yeah. Lorenzo, you all right?
Oh, yeah. I was just thinking.
Okay. Okay. All right, so attendance, I expect that you'll be here, doing the Zoom sessions. If you miss more than 2 of them, then I can drop you or fail you. I don't know how this is going to work, because like I said, some of you are going to be, this is going to be stuff that you could probably do without me showing you anything. It's stuff you've seen. So you might miss more than 2 classes. If you're doing well on the exams, showing up, doing well on the exams, I'm not going to be as critical as somebody who's not showing up and then coming to the exam and they're not doing well. So the attendance is really kind of, let's just see how it goes for you and, kind of go from there. Behavior, I mean, just, keep it clean in here. Let's just talk about math if we can. Let's not get political in here, obviously. Politics is what's going on in the world, right? We don't want to be talking about that. That'd be great to, but we can't. Okay, so that's pretty much it. There's a schedule down here. Let me get back to the home page. Okay, so right here is the class packet. So just click on that, download it, and open it up. And let me show you what that looks like. You know what? I think I already have it open. So here it is.
So you say we don't even need the book? Is that what you're saying?
There is no book. It is this packet right here that you click and download.
So I ordered that book. I should just turn it back, return it?
What book did you order? From where? Where'd you order?
From the bookstore. From
the bookstore. They're just going to send you this packet printed out.
Oh.
How much was it?
It was like books
12
with
bucks.
shipping and all that stuff was like 21 bucks or something like that.
Yeah, so you'll have a copy of it printed.
Oh, okay.
Everyone else has a electronic version.
Yeah, yeah,
It's probably easier to work off a printed one if you're
yeah.
going to do the work. So, I wouldn't return it. Just saves you having to print it out and stuff.
Yeah, yeah. Okay.
So here's the packet. It has all the topics that we're supposed to cover. And the way the packet works is the thing about this packet is the whole idea was to save you money, okay, so that you're not spending $150 for a textbook that you're going to use one time. So this packet costs you $20 whatever shipped, or free online. But it doesn't have a lot of explanation. It's just like this first section, multiplying and dividing fractions. It's just a bunch of problems. And I'm going to work through those problems. And as I work through them, I'll talk about, what are the techniques. And then we move on to adding and subtracting fractions, then some word problems. And then we get to the homework section, which is now this is the part that you do.
Oh, okay. So you're gonna refresh. You're gonna refresh us during that all those other ones, and then we get here and we should.
That's
know what
right.
we're doing. Yeah.
Yep. So my goal will be to work through as many of these problems before the homework as I can. I won't do them all because I don't have time, but I'll work through as many of those as I can. I'll get through, I think, enough to get you going on the homework, then you'll do the homework on your own. And then it moves on to the next section. So this is all still homework. So here's order of operations. So this is me. I go through these problems, solving linear equations. I go through those problems and linear expressions. And then there's the homework that goes with all that. Okay, so that's the way the entire packet is laid out. And then back to our homepage, here you have your schedule. If you click that, you can download it to your PC and print it out. And the schedule looks like this. It just lays out what we're going to do each day. So today, Monday, June 8th, is an introduction to the course, which we're doing now. We're going to talk about fractions. And then what you're supposed to do for homework is page 7 and 8, sections A and B, do only the odds. So you would go to, let's see if the page numbers match up. Page 7 and 8. Yeah, there we go. Page 7, see? Page 7. You're supposed to do page 7 and 8, only the odds. So why only the odds? Well, the evens are there for you to practice. If you've done the odds and you want to go back and do more, you have more problems there. So there's more problems there for you. If you do the odds, that should be enough for you to do well on the exam. But if you want more practice, you've got the evens. All right, okay, let me go back to the schedule. So we're supposed to do introduction to fractions, and today we're also supposed to do order of operations and linear equations. And the homework you do for that is on page 11 and 12, do sections A and B, do only the odds. Does that make sense?
Mm-hmm.
So the next time we meet, which would be June 10th, you should have this homework completed. Okay, you should have that homework right there done. I'm not going to check it, but again, this is not high school either. So it's up to you to get that done. And like I said, if you do the homework, then when you get to the test, there's going to be no surprises. Like the test will have problems that come basically from the homework. Of course, change the numbers, but the ideas are all going to be there. So then we come in on Wednesday, we do polynomials and applications, greatest common factor, percents and proportions. There's your homework assignment. And then look at what happens a week from today.
A test.
You already have your first test. So we have 5 tests and we only meet 16 times. So, we're having a test like, every few days. And what we'll do is we'll take the test at the beginning of class, and it'll be timed, so you'll have to finish it within a certain amount of time. And then after everyone's done, the time is up, then we will continue and we will cover the next set of material. So next Monday will be tests, followed by scientific notation, metric system, imperial system. And this is just the nature of the fact that you're taking an 8-week summer session. We're basically cut the time in half. And so we have to double the amount of information we cover in one day. Questions? That's the whole summer right there. Notice that there's not a review for the exams, right? Like I don't have like anything in the schedule that says, oh, we're going to spend some time reviewing. What I will do is before each test, I will give you some indication of what problems to focus on. So I will tell you, hey, but for this first test, I want you to look at your homework problems, and here are specific problems I think you should focus your attention on. And that it's kind of like a review in the sense that it narrows your focus a little bit more. And but there won't be like a formal review that I send to you that you go through this review and it's just like the test. So just be prepared for that. I mean, it's a review, but not really a review, if that makes sense. Okay, let's get back to the Canvas page. So you've got your class packet, your schedule. Okay, so videos of old class lectures. So when I do face-to-face classes, I record all my classes and I put all my videos up on YouTube. So I actually haven't looked at this in a while, so I'm just going to go here and take a look at this. Okay, so this is a college algebra class I taught from 2016. This is 4 years ago, okay? And so if you look at this, it has what I'm covering, but then after a while it doesn't. I'll have to go back and fix that. All this is just an additional resource. So let's say you can't come in for a Zoom session, or maybe even after our Zoom session, you want to go back and take a look at something. You can watch these. They're long. They're almost 2 hours long. But this first one is fractions in order of operations.
Which is the same thing we're doing, right, today?
Pretty much. They've changed the packet a little bit. So
Okay, we are recording.
I'm going to mute myself here and make this a little bit bigger so y'all can see this. So you can see it's just me. Maybe. This first one is me going through the syllabus with the class. All right, so that's it right there. Okay, so it's just me going through, working through problems. All right.
Mm-hmm.
So that's just an additional resource. Although also what I do here in Zoom is also going to be recorded, and it'll be posted for you. And I'll show you how I'm going to share my screen. You'll see how we're going to work through problems here in a moment. But that's there for you. Okay, files. If you click on files, this is just all the stuff that, the packet, the schedule. And then there's also some old exam reviews and solutions. Now, do not go in there and look at those and be like, oh, that's what the exam's going to be like. That's just old stuff, okay? If you want to go look at it, you can. It's there. It's just a resource. There's also solutions to the packet. So you know how the packet has the homework problems in it and stuff. Those are the solutions, but that's for an older packet. So don't know if it's going to match up exactly. I'm going to see if I can find the solutions to the new packet, because that new packet came out like, I think this summer. So I haven't seen the solutions yet, but if I can get my hands on them, I'm going to provide them to you, because I'm not trying to hide the answers to the homework problems from you. I want you to have access to them. So I'll get that for you.
Well,
If they're available. Pardon?
the packet has answers at the end, but it doesn't have solutions.
Just the answers.
Just answers. There's an answer key though.
Okay, all right, well then great. That's about all I would provide you anyway.
Yeah, it's at the very end of the packet.
Okay, good. I didn't know that. So yeah, so thank you. So in that case, when you're working through your homework problems, you can at least check to see that you got the right answer.
Yeah.
Now, if you're not getting the right answer,
You
then
do
that would be
something
when you
wrong.
reach out to me and ask for help. Because sometimes you can do the whole problem right and just miss one sign on something, and then it's going to be off. So, you know, that's why it's important for you to give me your work when you take your test, because, you know, I don't think you want this to be a class where it's either right or wrong. Because when it's wrong, it's wrong. Like, I don't want it to be that way. I want to see the process. I want to give you credit for showing me you know what you're doing. Okay. All right. Let's get back here. Yeah. All right. So that's pretty much this main page. We also have, let me go to student view so it looks like what you see. Yeah. Great. So discussion, there's a discussion board. If you want to talk to one another, you can go there. You're free to use that. You know, students will ask me always at the end of the semester, you know, is there anything I can do for bonus? Is there anything I can do for extra credit? You know, I would say that if you're participating on the discussion board with other students, asking questions, asking for clarification, talking to one another, using each other as a resource, that to me would be considered bonus. That's extra credit. That's you going beyond what I've asked you to do. So, you know, don't just go in there and be like, hi, you know, just make it, you know, you have to do something worthy of credit, but that's an opportunity for you.
Like if you need help on a problem or something or what?
Well,
Or
if
no?
you need help from me, I would come straight to me. And that again could be bonus too. If I feel like we're having good dialogue and bonus is going to be really me feeling like you're participating. You know, whether it be on discussion board with other students or with me, you know, I'll always factor that in at the end. Like Lorenzo, if I know by the end of the semester, I feel like I know what you know, that will factor in. If I don't have any idea, like you were here every once in a while,
Yeah.
never ask questions, don't, you know, then, you know, there's nothing much I'm not going to be able to do for you other than what you do on your exams.
Sounds good.
Okay, back to the syllabus. There's something in tutoring, and I think I put it in here. Let me get down to this. Oh yeah, I completely missed it. Okay, so tutoring. Of course, you could come to me, and I always recommend that you try and come to me first because, you know, everyone teaches things a little different, and the techniques are a little different. So if you need help and I'm not available, there's 2 different types of tutoring labs available to you, and they're Zoom, okay? But all you have to do is go here and click on one of these links. The first link is the Open Math Lab, and they have their hours of operation there. And that's just you go in and you can ask a question. And there's a one-on-one, there's a tutor there that will come in and help you. And they'll use an online whiteboard, and y'all can talk about the problem. And then there's this other tutoring, which is a one-on-one 30-minute session. And that's usually focusing more, like Lorenzo, you brought up, like you haven't done math in a while. They can try and identify some weak spots and then like focus like just on that and really drill it into you feel like you've got it. And so it's kind of your choice on those 2. I think on the one-on-one sessions, you only get 6 of them because it's funded by whatever. But I can assure you that if you go there, they will be happy to help you because these are people who, you know, are working, right? They're getting paid to sit there and wait for students to come in and ask for help. So how it went at the end of spring when this whole COVID-19 came about, but I know that they were telling us like encourage your students to go in there because they didn't have a lot of students doing it. So I feel like if you go there, you're gonna get help. I don't think they're gonna be overwhelmed and you're sitting there for 20 minutes waiting for someone. I think it's gonna be pretty immediate. Maybe y'all can tell me how it goes. I don't know. Okay, are there any questions before I kind of show you how we're going to be doing this? Uh-oh, my internet connection's unstable. Okay, I'm trying.
Did he leave?
Yeah, he did.
I think his internet dropped. No, I just got a bunch of candy. You know that thing Tokyo Tree? I ordered like a bunch of candy. It just came like mid speech. Little box.
Is this dude coming back or what?
Damn, I hope. He's
Hey,
back.
I'm sorry about that. I lost my internet. Let's see here.
That's a cool profile picture.
Mhm.
Let's see here. Share my screen. There we go. I don't know what happened. My internet got unstable and I lost it in the whole house for a couple of minutes. So, all right. Thank you all for hanging out and waiting for me. Hopefully that won't happen too often. Okay, are we good? Can y'all hear me at least?
Yeah.
Okay. I'm just going to not stream my video because it's just going to be me looking down anyway. Yeah, that picture was when this whole thing first started and I was doing my calculus class online. I went in like that and then one of my students took a screenshot of me. So, okay, here we go. So here's the way we're going to do this. So I'm going to bring up screen like this. And then I'm going to bring up the packet. And I'm just going to kind of work through problems here on the left side while we look at the problems on the right side. Kind of make sense?
Yeah.
All right, so let's see if we can't look at the first problems here. We're going to be talking about multiplying and dividing fractions to begin. So at some point you'll have the actual packet, so I don't necessarily have to really make sure that you can see this, but today we're going to act like nobody has it. So I'll keep it up there. All right, so the first thing we're going to be doing is multiplying and dividing fractions. All right, so this is, to me, this is a review concept. So if you have two fractions like this first one, number 1, 4/9, and we're going to be, that dot means multiplication, right?
Yep.
Times 3/16. Can somebody tell me like what it is? Like what is the procedure for multiplying two fractions together?
You gotta what you gotta do? You gotta
Is it like 4 times 16 and then 9 times 3?
Copy, dot, flip.
Okay, so what was that? Something flip?
Copy, dot, flip. I think that's what it is.
Okay, so I'm hearing different ideas. Let me actually, below this in blue, I'm going to write down what the actual process is. So if I have a fraction a over b and I want to multiply it times another fraction c over d. So we're doing this in terms of letters instead of numbers so that we have a formula. The process to do this is to just multiply straight across. So we're just going to multiply straight across the fractions. So we're going to do a times c and then divided by b times d. So I heard the flip stuff. We will do that, but that's division, not multiplication. So that is the actual formula for multiplying two fractions together. However, things can become problematic when we do this because numbers can get big, and we always want to have our answer in what's called its reduced form. So let me do it this way using the formula first, and then I'll talk about an alternative way that I think is better. So if I would just follow that formula, I do 4 times 3, and on the bottom I'm going to have to do 9 times 16. So 4 times 3 is 12, and then 9 times 16. What's 9 times 16?
oof, 9 times 6, 9, 12.
That's why we are allowed to have calculators, okay? Because we don't need to worry too much about doing the arithmetic.
It's 144.
44. Okay, 144. Now, this fraction, that is a correct answer, but it is not reduced. And we want to reduce all of our answers. So when we reduce, what we mean is, you know, if you take a fraction like, I'm going to do it down here. If I take a fraction 4/8, that is equivalent to the fraction 1/2. And the reason they're equivalent is because you would say, okay, 4 goes into both 4 and 8. 4 goes into 4 one time, and 4 goes into 8 twice. Does that look familiar, that idea of reducing fractions?
Yeah. You reduce it first before you do it, right?
Yeah, so that's going to be my second approach to this. The first approach I did, we just did straight across. We got 12/144. But now we have to ask ourselves, is there a number that goes into both of those? So can y'all think of a number that goes into both 12 and 144?
12.
12. Okay, but what if you didn't see that? It might be hard to see that. So you might say 2 goes into both of those because they're both even numbers, right?
Yeah.
So this is where things can get a little messy. Let's go with 12 though, because someone said 12. Why is this not erasing? That's really weird. I've never had that happen before. Doesn't want to erase. Huh. Something got changed on this. I'll have to change that. Okay, so 12 goes into 12 one time, and 12 goes into 144 how many times?
Twice. I mean, 12
12.
times. Yeah, 12.
Yeah. So this fraction actually reduces to be 1/12, and that will be our final answer. So the formula, even though it's nice, it could lead us to big numbers, like 12/144. So let me show you a second approach on this. A second approach would be to write the fractions down again. And at this point, you do the same thing we did earlier, but you do it with the numbers that you're looking at. So in other words, I'm going to look at, let's say, 4 and the number 16. I know of a number that goes into both of those, right?
Yep.
So 4 goes into 4 one time, and 4 goes into 16 4 times. So I can reduce those. Is there anything else I can reduce before I multiply across?
The 9 and 3.
Yeah, the 9 and 3. So I can think of a number. 3 goes into 3, and 3 goes into 9. So 3 goes into 3 one time, and 3 goes into 9 3 times. So if we do that before we multiply across, now what we have is 1/3 times 1/4. And now we just go straight across. And so we get 1/12. Same answer. Any questions on that? I'm going to do number 3 before we do number 2 to see if that's making sense there. So number 3, 21/24 times 16/18. By the way, do y'all see how I plan on doing this? I mean, like how I'm using the whiteboard and stuff. I mean, like this is pretty much the way I'm going to deliver the material. I'll write down formulas, definitions, anything I need, I'll just write it down here.
Yeah.
Okay. All right, so we could multiply straight across here, couldn't we? I mean, that is, the formula says you're allowed to go straight across. However, do y'all see how big those numbers would get?
Yeah.
Right, 21 times 16, 24 times 18. We don't want to do that. So let's see if we can't figure out if anything reduces first. So I'm going to look at the number, I don't know, 21 and 18. Is there anything that goes into both of those?
3, right?
3 goes into both, right? Is that the biggest number you can think of that goes into both?
Oh, let's see.
See, 4 doesn't go.
9. No, wait, no, never mind.
The 9 doesn't go into 21.
Oh, 6, 12,
Yeah.
18.
So I think 3 is the biggest number, right?
Oh, yeah.
That's kind of the game you want to play, is to try and find a number that goes into both, but the biggest one you can find. So 3. So 3 goes into 21 how many times?
7.
7. And then 3 goes into 18 6 times. And, you know, you could just use your calculator for that if you were unsure. You know, just go 18 divided by 3, you get 6. How about the 16 and the 24? Can we think of something that goes into both of those? Biggest number you can think of that goes into both.
8.
8, yeah, 8's a good one. I think 8's the biggest one.
Yeah.
Let's go with it. 8 goes in there twice, and 8 goes into here. What?
3 times.
Okay. So now this becomes really a 7 over 3 times a 2 over 6, right? Does anyone see that we could still reduce more?
Mm,
Look at the 2 over the 6. Doesn't 2 go into both 2 and 6?
oh, yeah.
I thought you couldn't do that.
You can. You can if it's multiplication. You're allowed to. In fact, when we were back up here, the 16 over 18, we could have, if we wanted to, reduce that first before we did anything else. It doesn't matter what order you do it. You want to get it completely reduced at some point.
Okay, I didn't know you could do that either.
Okay, so I'm going to reduce it here again. I'm going to go 2 goes into 2 once, 2 goes into 6 3 times. So now can I just multiply straight across right now? Are y'all okay with that? 7 times 1, 3 times 3?
Yes.
Yeah,
7 over 9.
there we go. That's the reduced fraction right there. So let's say you're taking a test, all right? And let's say you got to this point, and then the next step you did 14 over 18, right? You did the 7 times 2 and the 3 times 6. And you box it up and you give me that as your answer. What do you think I'm going to give you? Let's say if that problem's worth 10 points, how many points do you think you will have earned?
5 or less.
No, I'm not that mean. I think that's at least a 7 or an 8.
Oh, okay.
Because you've done some reducing, you just didn't reduce it all the way.
Yeah.
Okay, let's look at number 2. So number 2, I skipped it intentionally. Does anyone see why I skipped it?
Oh, it's division.
It's division. So that symbol that we have right there,
Now you do copy dot flip.
yeah. So the division symbol, I don't know if you've ever really noticed this or paid attention to it. It's really like it's like a box with a line over a box, and we're going to fill those boxes in with numbers. So that dot up there is like a box and like a box. So it's kind of like a blank a blank template for telling us we have fraction. But that's just a side note. But division is not multiplication, right? So the idea behind division is that division is what we call, I'm going to write this down so that you at least see it in words. Division is the same as multiplication of the reciprocal.
Oh, okay.
Okay, so when you take the number 7/8 and you divide it by 2/9, that's the same as taking 7/8 and multiplying by the reciprocal. Now, what's the reciprocal of something? It's that
9.
same thing flipped over. It's the fraction flipped.
So 9 twos.
9 halves. We would say 9 halves, but that's okay. I understand what you're saying. So who said that? Copy dot flip?
I did.
Okay, and Angelica or Angelica? How do I say?
Whichever. Angelica's fine.
Angelica. Okay. So Angelica said that she's heard something somewhere. Copy. I've never heard that actually. Dot flip.
Yes.
Okay, so copy dot flip. So basically what she's saying is what you're going to do is copy down the 7/8, you're going to put, instead of a division, you're going to put a dot, and then you're going to flip this. So division is copy dot flip. I'm happy with that. Do y'all like that?
Yeah, sounds
The mathematical way of saying it is multiplication of the reciprocal, but copy dot flip I think is kind of nice. Okay, so now that we're here at this point, 7/8 dot times 9/2, should we do some reducing? Should we see if we can reduce anything?
I don't think you can.
I don't think we can either. I don't see anything that's going to go like 7. Nothing goes into both 7 and 8. Oops. Nothing goes into both 7 and 2. 9 and 2. No, 9 and 8. Yeah, I think we're complete. There's nothing to do. So we just multiply straight across. So 7 times 9, that's 63 over 16. And box it up. So I have a question for you. The original problem was 7/8 divided by 2/9. At this point, could I have done 2 goes into 2 once, 2 goes into 8 4 times, and then do my copy dot flip?
I don't know.
The answer is no. Absolutely no. You
9
cannot.
over 1 is just 9, right?
Pardon me?
Is 9 over 1 just 9?
It is 9. But the problem is, you know, when you're doing canceling like we've been doing it, you're only allowed to do canceling when you have multiplication.
Oh, okay.
See, we don't have multiplication yet. We still have division here. And so you can't cancel things until after you've turned it into multiplication. And so that's why this is a no-go. So whenever you have a division problem, always do that flipping over first, then go try and do any canceling. Don't get that backwards, or else it'll be wrong. You can see here that if we would have kept that and done it 7/4 divided by, we would have had 1/9. If we did our copy dot flip here, we would have had that, and then that would have been 63/4. And these are obviously not the same answers. And so one of them is wrong, and I'm telling you the one I did down here in red is wrong. Okay, let's look at number, let's look at number 6, because 6 is the first time we've seen this other type of this other form. Now, I know it looks bad, but okay, so let's just take a detour here and let's just look at this for a second. 1 with the 4/9 next to it. So the way we would say that is 1 and 4/9. 4/9. Okay, 1 and 4/9. That is what we call a mixed number. It's just another way of writing a number down. It's called a mixed number. And in this class, we will work with mixed numbers, and we will also work with numbers written, well, I should say it this way. When we're working with fractions, there's basically 2 different forms that we can work with them in. One of them is the mixed number form, and the other one is what's called the proper or improper fraction. So we have mixed number, and then we either have proper / improper fractions. Okay, those are the 2 different forms that when I write a number down, those are the 2 main, or when I write a fraction down, those are the 2 main ways that you're going to see them. So what we're going to want to do when we multiply or divide 2 numbers together, if they are mixed numbers, which they are in this case, right? These are mixed numbers because it's a number with a fraction next to it, number, fraction next to it, number, fraction next to it. That makes it a mixed number. The first thing we're going to do is convert them to improper fractions. So does anyone remember how you do the conversion from this to an improper fraction?
You multiply the whole number by one of the, I guess, like denominator or numerator. Yeah.
Yep. So you're going to take that. You're going to take that number 1 right there, and you're going to multiply it. I'm going to put M-U-L-T. You multiply by that, and then what do you do after that? There's one more thing you have to do. You take. So you're going to do 1 times 9. That gives you 9, and then you have to do one more thing.
By the top, times it by the top too, or no?
You add that top number.
Oh yeah.
Okay. So let's try and do that. For that first one, I'm going to do 1 times 9, which gives me 9. Then I'm going to add 4. What do I get when I add 4 to 9?
13.
13. So I'm going to write that down, 13. And then I'm going to write that over. What do I write it over? Remember? Whatever this number was down here, the 9. Okay, it's always going to be that number. So 13 over 9. So that's how you convert from a mixed number to, this is called an improper fraction. I'll just put improper. We have to do that for both of them. We have to do this one, which is also a mixed number, and convert that to an improper fraction. So let's see if we can do that one in our heads. We're going to go 2 times 4, right, which gives us 8. Then we're going to add to that 1. So what does that give us?
9 8.
Oh, shit.
9 over 4.
9 4.
Whoa.
Oh yeah.
There you go. Are y'all still with me?
Yeah.
Yeah.
Yeah. I'm not sure what happened. Okay. For some reason, my screen over here, I lost y'all. I can hear y'all though. So, what does that become?
9 4s.
9/4. Okay, good. Just give me a moment. I gotta try and share my screen. Display. There. All right, I'm back. Y'all can see my screen, yes?
Yep.
Okay. So this one became 9 over 4. Okay, so now let's rewrite the problem. This first fraction became 13 over 9. And then we have divided by, and the other one is 9 over 4. Okay. Let's see, I'm going to pick somebody here. Jordan, are you around? I have all these students that don't have video, so I have no idea if they just like are here and then they're out like playing basketball in their front yard. No, Jordan? Okay. I don't need to see you, but I might be calling on you just to see if you're there. Let's go with...
Sorry, my internet was cutting out. I couldn't hear what you were asking.
Okay, yeah, Jordan. I was going to ask you, are you following where we are right now?
I'm trying to. My internet's just really bad right now.
That's fine. Let's go with, how about, is it Noe?
Yes.
Okay. I said that right, Noe?
Yeah.
Okay, Noe, are you okay with this one?
Yeah, kind of.
Okay. So we have 2 fractions, right? And we're dividing them. So what do we need to do?
First you put the 13 9.
Okay, 13 over 9.
And then the dot.
Yep,
And then you flip the fraction.
yep. There you go. Good. So I was really, I don't know how this seems to you, but for me, it's like, it's so tempting to want to cancel these 9s, isn't it?
Yeah.
It's like right there. It wants you to do it, but don't do it because you can't do it until after you flip. And then once you flip, you can't cancel them because they're both on the bottom. Now, can we cancel anything here? Can we reduce this or not?
No.
No, we cannot. I need to get this thing out of here. I've got this big bar in my way. There it goes. All right.
I got a question.
Yes.
Can you scroll up just a little bit?
Yep.
On the left. That first one, it goes into a 9. How to do that?
The one on the left here?
Oh yeah, no, the on the right.
Oh, on the right.
one.
Okay.
It
So what
turns
you
into
so what you do is whenever you have an improper fraction, or sorry, a mixed number, you're always going to multiply the 2 times 4. So you're going 2 times 4. Sorry, I'm going to put a dot there instead. You're going 2 times 4, and then you're going to add to that whatever's up here.
Oh, okay. I didn't know it was like step by step.
Yep. 2 times 4 gives you the 8, and then you add the 1. That gives you the 9, and then your denominator, the piece on the bottom, will always be whatever the bottom one was there. I'll show you in a minute why it is that, okay? I'll show it to you because I think it kind of sucks to just give you that and it's like, why, you know? Maybe we don't care why, but. Okay, any questions before I proceed? All right. So I do want to mention something here, kind of off topic, but on topic. A question that I'm sure you've sat there and toiled with your, doing this math is this question about, why? I'm going to share my video here. So the question of, why are we doing this? Like, when am I ever going to need to convert a mixed number into an improper fraction and add them or multiply them, or right? And I think it's a very valid question. And I really have just one answer for you that I think hopefully you'll maybe not agree with, but understand. So everybody is in college because you want a piece of paper, right? You want a degree for something, and that should help you get to a position in your life that you maybe couldn't get to without that piece of paper. So normally someone who has a degree has the potential to earn more money than people who do not, even though it's not always that way, right? So it's at the end of this whole thing, you want a piece of paper. Am I completely off by saying that, or do you all agree with that sort of philosophy?
Agreed.
Yeah.
Yeah, okay. So,
Yeah.
What does the college degree mean? Well, it's just like, who was Sarah? Were you the art? Sarah, did you say you were art major? Who was it?
I am Brianna.
Brianna, okay. You're on my screen. You're like right underneath Sarah. So okay. So like art, you're not going to be doing this math, right? So why do you need to do this for an art degree, right? It just doesn't make sense. Well, the way I look at it is the college degree, what it shows somebody is you have an ability to learn. It's all about learning. I don't necessarily like art, right? No offense, Brianna. I mean, I do like art, but it wasn't something that when I, went to college, I was like, I want to do art. But I actually had to take some art classes. And I learned about art. Went to a few museums and, learned a little bit. I also had to write a lot of English papers, which I'm not an English person. I hate writing papers, but I had to read. I had to read books. I had to write. At the end of it, I have a piece of paper. Actually, it's sitting right. Which one is it? One of those degrees there. I don't remember which one is my bachelor's. So that all that says is that I know a little bit about a lot of things, and that I'm capable of learning things even if I'm not that interested in them. And so as an employer, somebody trying to hire you for something, a college degree just means that you have the ability to learn. If they need to teach you something that you've never seen before, maybe it's how to use this or how their procedures work within their company, you are not like one of those people where like you tell them something and then 5 minutes later they're like, what? Can you show me that again? They don't have to show you like 10 times. You have the ability to learn. Does that make sense to you all? And in all these different courses, math uses a certain part of the brain. And so we're not saying that you're going to be like this super strong math person, but you at least have some parts of your brain that when you get things going, you can process information a certain way. Art is different. It's a different part of the brain. And you know that I don't have that. English, I don't have that. There's a lot of things I don't have. Math is the one thing that I am really good at, but you're going to go and find the thing that you're really good at, but you'll be rounded. You'll have an exposure to other things. I hope that that makes sense, because really, this isn't about the answer being this fraction and like what it means. It's about, we have a procedure here, don't we? It's looking at the problem, recognizing what it is, flipping it over, canceling. That's all a certain gears in your mind that have to turn a certain way for that to all work right. So I hope that that in some way helps you as you sit here and go, why are we doing this? Why are we doing this? And then I'll add one more thing. So you have, normally in academics, you have 3 different degrees that you can achieve. You have your bachelor's, which is usually a 4-year degree. And then you have your master's, and then you have your PhD. And so if you're not familiar with the differences between those, I have a real kind of cool little, I think it's cool, a way of explaining what they are. So let's say you have a bachelor's degree in art, Brianna, right? What that means is you know a little bit about art. You know a little bit about art. And or you know a little bit about a lot of different things. Let's say it that way. You know a little bit about a lot. You get a master's and you know a lot about a little bit, like a lot about less. So if Brianna, if you were to get your master's in art, you would know a whole lot about art, right? If you get your PhD, then you basically know everything about one thing. So Brianna, if you were to get a PhD in art, I don't know how that happens, but if you were, then you'd probably be like a specialist in like a certain era, maybe a 4-year period of art in Greece or something like that. It would be like so specialized that another person who had a PhD in art would have no idea what it is that you know. So it's like branches on a tree. You know, your bachelor's degree is like the trunk, and then you get your master's, you go down a certain branch, and then you get your PhD, you're just looking at one little leaf on the tree. You're a specialist, you know everything about that leaf. And that's the way academics works. So if you become a doctor, same thing, right? You can become a specialist on one particular aspect of the human body. Okay, I'm done. I think it helps keep things in focus, that it's not about the math, it's about just general learning. All right, so we're moving on. How are we doing on time? Y'all want to do a break or keep going? It's 12:20.
Keep going.
Keep going. Let's just grind it out for this first day. I know it's, and I can already tell we're probably going to fall behind, but it's okay. We'll be all right. Okay, so now we're going to do adding and subtracting fractions. So if you think back to grade school, if you can remember that, when you're learning about numbers, don't you actually learn how to add and subtract first?
Yeah.
Mm-hmm. And then you learn multiplication and division later. So why is it with fractions, we actually are doing it in reverse order? We're doing multiplication and division first, and now we're going to talk about adding and subtracting. Can anyone tell me why you think we're doing it that way?
Because multiplying and dividing fractions is the easier version of it.
Yep, multiplying and dividing fractions is easier than adding and subtracting them. To add and subtract 2 fractions, you actually have to have what's called a common denominator. They both have to have the same denominator in order to add them or subtract them. So it's more involved, it's more difficult, and so we do it after we do multiplication. So before I begin this, adding and subtracting, I want to point something out to everyone. Does everyone agree that if I take any number, like the number 4, and I multiply it times this special number 1, that nothing happens and we just get 4? Right? If I take the number 8 and multiply it by the number 1, nothing happens, we just get 8. So the number 1 has a very special property that whenever you multiply anything by 1, nothing happens. It stays the same, right? So that's the first thing that I want everyone to understand. Multiplying by 1, that's a 1. Nothing, changes. All right, so that's the first thing. Sorry about how sloppy that is. Nothing changes if we multiply a number by 1. The next thing I want you to also agree upon is that if I take any number and divide it by itself, it is 1. So if I take 5 and divide it by 5, we get 1. 3 divided by 3 was 1. 9 divided by 9 is 1. Do we all agree with that?
Yep.
Okay. So divide a number by itself, we get 1. Okay, that's the second thing I want everyone to agree with. All right, so multiplying by 1 changes nothing, and dividing a number by itself, you get 1. All right, now let's talk about why things are so tough when we add fractions together. So I'm going to do this with a picture. Let's take a look at a candy bar. If I have a candy bar and I cut it into 4 equal pieces, and I ask you to take 2 of them, then that would be half the candy bar, right? But then if I ask you to take that and then also take another candy bar and cut it into 5 equal pieces, and to take, let's say, 3 of those, then how many would I have if I add that together? How much of a candy bar do I have? Half a candy bar plus, how much of that other candy bar do I have? How many pieces? In the second candy bar, how many pieces do I have?
2.
In the second one, I have 3 pieces out of 5, right? In this first one, I have 2 out of 4. Do y'all see how I'm creating this fraction? The shaded part is how many pieces I have, that's 2, and there are 4 parts total. So I'm taking 2 of the 4. On the bottom one, there's 3 shaded out of 5, so I say 3 fits, or 3 over 5. So how much do you have if you add them together? That's not easy, is it? Do y'all agree that that's not easy?
No.
Okay, let me try something else. What if I did 5 equal pieces? I ask you to take 1 of those and 3 of those. Can you tell me how much you have now? So so what's different about these 2 problems is that this first one, you have 1 out of 5, right? And the second one, you have 3 out of 5. So how many do you have total? You have 4.
4/5.
4 out of 5, yes? So when you have the same number of parts, it's easier to add things together than when you have different parts. And that's why adding fractions is difficult, okay? Is because of this sort of illustration. So let's get to the method, all right? I'm just trying to illustrate why it's difficult to add fractions in general. So let's go with this first example, number 7. So I have 1/8. I'm going to add to that 2/5. All right, so again, right away we know this is bad because we don't have the same denominator. So if you look at like candy bars, this is like I have 1 piece out of 8, and then this other one I have 2 pieces out of 5. So how many pieces of a candy bar do I have? I have no freaking idea because those don't match up. So what we're going to do to start is make those two numbers be the same number. So I want to try and make the 8 and 5 be what we call a common denominator, a number that is a multiple of both. So it's got to be a number that is a multiple of 8, but it's also got to be a multiple of 5. So I'm going to do this on the side. I'm going to list out the multiples of 8 and multiples of 5. So when I say multiples of 8, I'm saying like, what's 8 times 1? What's 8 times 2? What's 8 times 3? What's 8 times 4? What's 8 times 5? What's 8 times 6? And I'm just listing out the multiples. And then I do the same thing for 5. 5, 10, 15, 20. Any questions on what I'm doing? 25, 30, 35, 40, 45. What am I looking for?
So it's going to be 40, same.
Yeah, I'm looking for a number that's in both lists. And that number 40 is called our
Common denominator.
least.
Oh,
common.
least. Oh.
It's called the least common denominator because it is the smallest number that's on both lists. There are some other numbers that are on both lists. Do you all agree that the number 80 is on both lists? Right? But that wouldn't be the least common denominator. It would just be a common denominator. The least one, the smallest one, is 40. Okay, so now let's try and see, is there a way that we could turn this 8 into a 40? What would we have to multiply 8 by to turn it into a 40?
By 5.
A 5, right? But we can't just multiply this, we can't take this fraction and just multiply it by 5 because then it's not the same fraction, is it? So we're going to use that property I told you about earlier a little while ago. Didn't we say that multiplying by 1 never changes something? Right? So what I'm going to do is...
Let's multiply the top.
Yeah, we're going to multiply this thing by 1. Just this one right here. We're going to focus all our attention here. We're going to multiply that by 1. But the one that I choose is going to be very clever. Because I really want to multiply the bottom by 5, right? The 8 by 5. So that 1, I'm going to write it as 5 over 5. Why am I using 5 over 5? Because 5 over 5 is 1. Because you all also agree that any number over itself is 1. So I'm multiplying that first fraction, 1 over 8, times 5 over 5. And then what do you think I'm going to do on the second fraction? I've got to multiply it by something, right? I got to multiply it by 1. But I need to turn the 5 into a 40. So how do I turn the 5 into a 40?
Times it by 8.
Multiply by 8. But that 8 has to be 8 over 8 so that it's really a 1 and that it doesn't change anything. Now what hopefully you recognize is that what's here on the left in green is multiplying two fractions.
The second fraction, are we multiplying it by 7? Or is it 8?
The second.
So 2 over 5.
8.
Sorry, I've lost you. I don't understand your question.
It's 8, not 7.
Okay.
It's 8 because we're trying to turn that 5 on the bottom. We're trying to turn that 5 into a 40. And so we have to multiply 5 by 8 to get 40.
Okay.
So what I've highlighted here in green and in blue now, do you all see that those are just multiplication of fraction problems? That's the previous section. That's the previous section that we talked about. How do we multiply fractions? Straight across, right? So we're going to multiply the 5 times the 1, the 5 times the 8. We're going to do the 2 times the 8. We're going to do the 5 times the 8. We're going to just do that straight across. So let's do that. We get 5 over 40. That comes from here. Plus what?
Plus 8 times 40. 16 over 40.
16 over 40. Okay, now that we have the same denominator, now and only now are we allowed to add these without doing any more work. So we are going to add these. All we do is take the 5 and add it to the 16. So 5 plus 16 gives me 21. And then what do we do to the denominator? Be careful here.
You keep it the same.
Keep it the same. It's 21 out of 40. 21 periods. Okay, I know that this, if you don't remember this, I know that this is a lot to try and kind of in all at one time. So I'm going to just try and write down a quick formula for us. So if you have a fraction, a over b, plus another fraction, c over b, and I want you to understand here, these have the same bottom, don't they?
Yeah.
Same denominator. If you have that, the answer is just a plus c over b. So you just add their numerators up, and then you keep the denominator the same. That's the formula. Versus another formula, what if we have a over b plus c over d? Now, this time, are the denominators the same?
No.
No, so we have to go get a common denominator. And the way we do that is to multiply by the 1, and that can be weird because you have to get a least common denominator. Do you all agree that that's a little more involved?
Yeah.
Yeah. But guess what? There actually is a formula. There is a shortcut. There is a way to do it without doing any multiplying by 1. So I'm going to give it to you just so you have it. I'm going to write it down first, and then we'll talk about what we're doing. If you like formulas, there's one right there. So the way this formula works is like this. If you want to add two fractions that do not have the same denominator, all you have to do is just plug things into this formula right here. And a way to remember it, I guess, is that what's happening here is you're multiplying a times d, that's where this comes from, and then you're adding to it, multiplying these two together, c times b. I made a mistake there, I wrote that down. This is a b. Sorry about that. Y'all see that? I fixed that. So c times b is that one. And then over b times d, which is this piece. We'll do it as an example, but I just want to at least give you the formula. Okay, so let's do that. Let's use that shortcut formula. If you don't like the shortcut, you don't have to use it, but we're going to take this right here. Same problem we just did. Do we have the same denominator? No, right? So let's use this formula. So I'm going to multiply first 1 times 5, and that gives me 5. Then I'm going to put plus, and now I'm going to do 2 times 8. What's 2 times 8? 16, right? And then I'm going to go over, and now I'm going to do 8 times 5. And what's 8 times 5?
40.
And now what we do is we add the top, we get 21 over 40. Is that the same answer?
Oh, dang, that's a lot easier.
A lot faster, isn't it?
Yeah.
Now there are some drawbacks to that formula, all right? I'll illustrate it for you in a moment. But let's do number 8 before we do anything else. Okay, so for number 8, we have 7 3/5. What type of number is that when we write it like that? 7 3/5. What do we call that type of number?
Mixed numbers.
Mixed number.
Fraction.
Yeah. So let's convert it first. We don't like to work with things in mixed numbers, okay? It's just, they're problematic. So let's convert it first. We're gonna go 7 times 5. That's 35. I'm gonna just write this down, 35. And then we're gonna add to it whatever the top is, which is 3, gives us 38. And we're gonna do that, 38
Over 5.
over 5. and then minus 1 over 2. Okay, do y'all see we have subtraction instead of addition?
Mhm.
Okay, the good news with fractions when you add and subtract them, the only difference between addition and subtraction is that you're going to use minus instead of plus. So would y'all like to try the shortcut again? Let's do it. Let's do it. So I'm going to say this equals, I don't even care that they don't have the same denominator. I'm going to go 38 times 2. All right, what's that, 76?
Yeah, 76.
76, I'm going to write that down, 76. Now, am I going to do plus, do you think, or minus?
Minus.
Minus, yeah, because there's a minus sign there, so I'm going to do minus. Now I do 1 times 5, which is just 5. And then I divide that by 5 times 2, which is 10.
Mhm.
And that should give me 71 over 10. There we go.
So I have a question.
Yep.
So the only time you use that formula, the A times D plus B times C, the only time we use that is if it doesn't have a common denominator, correct? But if it does, we don't use that formula?
If it does, you actually could still use it. It's just like, for example, look at this one right here. Let's say we have 3/4 minus 1/4, okay? The simple way to do that would just be 3 minus 1 over 4 because they have the same denominator, and that would be 2 over 4, which is 1/2, because 2 goes into each of those. Does that make sense, Anthony?
Yeah.
Okay,
Yeah,
now,
it does.
but if you wanted to use the formula, you could. You would go 3 times 4, which would be 12. You would subtract from that 1 times 4, which would be 4. And you'd divide that by 4 times 4, which is 16. And you would get on the top 8 and on the bottom 16. And guess what that is?
1/2.
That's half.
1/2, because 8 goes into both of those. So you could just stick with that formula. The one drawback to that formula is that your numbers can get big. And sometimes this answer you get at the end is hard to reduce because your numbers have gotten so big. I can give you a real quick illustration. I'll keep that on the page. Look, if I did something like, if I did 2 over 11 plus, let's say, I'm just trying to think of how bad I want this to be. 13 over 3, okay? I'm not going to make it too bad. If we do this and we follow the method, we go 2 times 3, right? Which is going to be 6, and then plus, and then we do this. See, our numbers are going to get real big here?
Yeah.
And then over, I'm not even going to calculate that, over 33. So we're going to get a huge number here on top. But if you do it the other way, where you find a common denominator, the common denominator here would be 33. So you'd multiply the top and bottom here by 3, top and bottom here by 11. You're actually going to have big numbers there too. But that was a terrible example. I apologize. You have to trust me that sometimes your numbers can get really big this way. You'll still get the right answer. As long as you reduce it, you'll get the same answer. It's just that sometimes it's faster. I think this one was a better illustration of how if you have the common denominator, just use the first formula. It's a little easier, cleaner.
I have a question.
Yep.
When you're using the formula, I noticed you changed it to subtraction. Is that when you're subtracting, you change the sign to subtracting, and if you're adding, you change it to adding for the formula?
Yep. So I'm going to go back to when I wrote the formula down here. I'm going to erase some of these cross things here. If you change this to a minus, then that just becomes a minus in the formula.
Okay, cool. Okay, thank you.
That's the only thing that changes. Yep.
Thank you.
Same with this one up here. If that's a minus, then that becomes a minus. So both formulas work the same way. Okay, I'm going to show you one more thing before we move on to the word problems. So when we were converting, just a second ago, we converted 7 3/5, we said was a mixed number, right? And we converted it to an improper fraction by doing that whole 7 times 5, then add 3, right? Didn't we do that?
Yeah.
Okay, here's why. Because what this really means is 7 plus 3/5. That's what it really means. When you write this down, you really mean 7 plus 3/5. And then if I write 7 as 7 over 1, because isn't 7 over 1 still 7?
Yeah.
Okay, then we have that, right? So check this out. Let's do that little cross thing. What would we do first here?
7 times 5,
7 times 5.
which is 35.
And then we would add to that. Now, I'm going to put this in red. We would do this 3 times 1, wouldn't it?
Yeah.
Okay. But if we have a mixed number, isn't this number out front always going to be here? And isn't it always going to have a 1 underneath? Like if that number out front was a 4, that's going to be 4 over 1. If that number out front was a 5, it'd be 5 over 1. So isn't this multiplication that we're going to do right here from the 3 down to there always going to be just the 3? Just 3 times 1, which is 3. So we're going to add to this 3. And then when we do the bottom and we multiply, isn't that always just going to be 1 times whatever this bottom was? Which is the 5, right?
Yeah.
So go back and think about this. When we did this to start, we said 7 times 5. There it is. Then we added to it what? The 3, because we know that's always going to be there. And then we said, let's just keep this bottom one, right? That's because it's always going to be that bottom one.
What?
So it's just a short way, but what we're really doing is adding those two things together. Just in a very, very condensed system. What's the word I'm looking for? Just like a plug and chug formula. There's no thought process to it. It's just do it, right? But I wanted you to see the mechanics behind it and why it makes sense to do it. Okay, word problems. This will be interesting. You know what? 1240. Why don't we do this? Who does not have access to the packet right now? Who does not?
Should we have already downloaded it?
No, you shouldn't have, but I mean, you could right now, if I gave you a few minutes, you could go back to Canvas and you could download it, right?
Yeah.
So like, let me see if I can go back to this. So here's what I'd like to do. I think this will be fun. Well, fun is relative. We're doing math in the middle of the day here. I'm not quite sure how fun that is for most of you. Go back to, take a minute to go back to Canvas on your computer and see if you can download the packet. And then what I'm going to do is I'm going to break y'all out into rooms. And I'm going to put, let's say, 3 people in each room. And then I'm going to let y'all read these word problems together and see if y'all can't come up with, the process to figure out the answer. The only hint that I can give you right now, without me working these out myself, the only hint that I can give you is that it's going to involve multiplication or division of fractions or addition and subtraction of fractions. Does that sound like a decent idea?
Yeah.
You all okay with that? So here's what we'll do. Let's take, I have 12:45 on my clock. Let's take a 5-minute break. At 12:50, when you come back, hopefully you'll have the stuff downloaded, and then I'm going to invite you into a breakout room. And I'm just going to randomly assign y'all 3 people together, okay? And then when you get back to your computer, just accept the invitation. You'll go into that breakout room together, and y'all just talk through it, see if y'all can come up with an answer. When you're in the breakout rooms, you can actually raise your hand and ask for me, and I can come into the breakout room if y'all have a question. and let's just see how it goes. And then eventually I'll force everyone to come back as one group here. Okay, so 5-minute break, come back at 12:50 and you will have been invited into a room. I'm going to take a break too, just for a few minutes. So if you need me, just hang tight.
Do y'all know how to get out of here?
Okay, I'm back. Can you hear me okay? Is it Diana? How do you say your name? Diana?
Diana.
Diana, okay. All right. Did you get invited to a room?
Yeah, I'm gonna join it right now.
Okay. Angelica, were you able to join in? Are you back yet?
Yes.
Okay. Hey, Dave, did you get an invitation to a breakout room? Hey, Dave, did you get an invitation to a breakout room?
Sorry, let me see. Yes, two.
Okay, go ahead and jump in
Yeah.
there and see what they're doing. Okay, cool.
Okay. And
Oops.
Brendan.
Shh. Oh, baby.
Sorry, I got stuck with my niece. It's my mom's birthday, and I don't know where everyone else went.
Ew.
Thank you.
Okay, so everyone, I think everyone's back. So what do y'all think of that breakout thing?
It was cool.
Is that okay?
that's pretty good.
Okay. I mean, at least if anything, it'll break the monotony of sitting there listening to me. So, you know, I'm going to try and do that throughout just so we can, you know, make this somewhat enjoyable for you. Okay, so a couple of things. I didn't talk to every group about this, but let's just make sure we have the correct answers for the first few. Number 11 was 8, right? Number 12 was 8. Number 13 was, what was number 13?
33 and 1/4.
30, was it 33 and 1/4?
I
Yeah.
got stuck on number
Yes.
13.
Let's talk about,
We
okay.
did the 143/4, but you said it was 35 and 3/4, right?
Yeah, well, maybe there was something wrong with what y'all did here. So let's just talk about number 13 real quick. Number 13 was a dog that weighed 127 3/4 pounds, and another dog that weighed 94 and, well, come here, 94.5 pounds, right? So we convert these over first from mixed numbers to improper fractions. And let's see, 127 times 4, then add 3. We had 511 over 4, and then minus, this one was 94 times 2, and then we add 1. So 189 over 2. So that's what we're supposed to do, that operation right there. And now a lot of people use the shortcut. So this is where we do 511 times 2. I'm just going to double check this because when I helped that one group out, we didn't verify this. This was 1022. Subtract from that 189 times 4, which is 756. And then over what?
Oh, we got the wrong number.
It was 8.
I think that's 8, right? And now you go 1022 minus 756, so you should get 266
Oh, man.
over 8. It's okay. I mean, y'all did the right method. It's just,
Yeah.
I think y'all messed up this number. I don't know.
We put
This is for
280.
number 13.
I just put them in the wrong position.
This is 13.
And what was the answer?
Well, I'm not done yet.
Okay, okay.
I think we added instead of subtracting.
Okay, yeah. So they were trying to find the difference in the dog's weight. So the
We put
difference.
286 for some reason. I don't know why. Instead of 266.
Yeah, no big deal. All right, so 266 over 8. That is a correct answer, but we want to be able to convert this back to a mixed number, and that's the one thing I just want to go over real quick. To convert back to a mixed number, what you have to do is break out the old division that you learn in grade school. So like do that. So you have to sit here and go, okay, does 8 go into 2? No. Does 8 go into 26? If we multiply it by what, we can get close to 26, but not quite go over. We have to multiply it by 3, right? That gives us 24. So 8 times 3 is 24. We put that underneath here. And then we put a 0 here and we subtract. Does this all look familiar to everyone?
I never learned long division.
No? This is, who said that?
That's me.
Wait,
It's me, Edward.
Edward, okay. So if this is actually called long division. So if you have not, then I would recommend this is something that you either want to go hit up the tutors for or make an online thing with me where we can go through it, because long division does come up in this class. So I'm going to continue.
I have a question. I'm sorry.
Yep.
When we're showing our work, do we have to show the long division, or can we do it in our calculators?
Well, how are you going to get that in your calculator? Like just have it convert from that to a mixed number? Like is there a key on your calculator?
Oh.
Some scientific calculators have a thing where whenever you divide it comes out as decimal, you can convert it into a fraction.
Yeah, but when it does the fraction, is it going to give you 266 over 8, or is it going to give you 30 something? See,
It'll automatically simplify it into the smallest form.
But will it be a mixed number is my question.
There's a key on there for mixed numbers.
Yeah, so if you have the right calculator, you can. I think everyone in here should be comfortable with long division though, which is why I'm showing it here, because I would take this answer, 266 over 8, I would take that full credit. The problem with that is you're not really answering the question, like what's the difference in weight of the dogs, right? And your answer is 266 over 8. So by getting it into this form, I'm going to continue this long division. We're going to subtract and we get 26. We multiply by 3 again. We get 24. This time we have no more numbers over here. So this is our remainder. So our answer is always going to be these two numbers, 33, and then our remainder divided by our divisor, which was 8. And 2 over 8 reduces to be 1/4. So 33 and a quarter pounds, the difference between the dog's weights. That, to me, that answer makes more sense from what was being asked, right? Like in terms of it, it's like this. Has anyone here ever gone to like the HEB deli and ordered lunch meat?
I know those days, yeah.
Okay, like where you go up and you tell them, I want like, I don't know, 1.5 pounds of this or something, right? Has anyone ever walked up to somebody at the deli and ordered 3/2 pounds of anything?
No.
No, you should do it just for fun. Just go up there and be like, I'd like 3/2 pounds, and see what they do. Like they'll freak out and look at you like, what? Well, 3/2 is actually, if you do long division, it's 1, 2, 1, that's our remainder. It's 1.5 pounds. So my point is this mixed number, 3/2, converts over to 1.5. 1.5 pounds of something is something that makes sense to people. 3/2 pounds is not a number that we use all the time.
I just, when I did it right now, just changed the 1/2 into 2/4. And then I solved it like that, and I did get 33 and then 1/4. Was that like a valid way of doing it, just like doing it like that?
What did you do?
Because it's 127 and then 3/4 minus 94 and then 1/2. I just made it 2/4 instead of 1/2. Was it like valid?
Yeah, that's okay.
Oh, okay.
Yeah.
Whenever we're showing our work on the stuff for the fractions, in my head, I always I convert it into decimals and then do all the adding and subtracting that way. If we show our work with that, will we still get credit for that? Or do we have to show it as doing it with everything as a fraction?
So the title of this section is fractions. I realize that we can get on our calculators and we can do all of this pretty much with the calculator and get decimal answers.
Well,
Yeah.
I mean, like with the answer staying as a fraction, but all of our work is done in decimals. Will we get only partial credit for showing our work as that, or do we have to show it all as fractions in the work section?
So I'm thinking the idea behind this section is for you to understand the technique of adding and subtracting fractions, not using your calculator to get to the same answer. This goes back to the whole idea of, like, you know, education and what are we doing this for? Look, if I had to do this, like in the real world, I'm not doing fractions. I'm doing decimals. I'm doing my calculator and I'm done. Okay. This is more about the procedure through here. I think later on, we will get to the point later where we're just going to use our calculator for everything. Okay. But this first section, let's just on this first test, see how much we can do using the mechanics that we've learned here. And then once we get to the decimal section, we can use our calculators all day long. That sound okay, Dalton?
Okay.
May not be the answer you want to hear, but I mean, I think it's a tough one because if you get the right answer, you get the right answer, right?
Yeah.
You know, but it's more about the procedure than it is the answer to me. Okay. So I have, I should say one more thing, Dalton. There are problems that I could give you that have non-terminating repeating decimals.
Right.
That then you would have some issues, but
yeah,
I wouldn't intentionally do that. Okay. So I have this question for you all. I want to see what happens here. Okay, that's it. 16 divided by 2 times 4. We're moving into the next section. We only have 8 or 9 minutes left. But I just want you all to kind of sit there and look at that, see if you can figure out what the answer is. But don't use a calculator, just use your mind. And I'm going to try and do a poll here. Let me see here. Oh, man. I have to do this beforehand. Give me just a second. Y'all are getting this answer right. Yeah, I'm not going to be able to do the poll right now. Okay, everyone have their answer?
Yeah.
Yes.
Does anyone want to share their answer with me?
2.
2. Okay, I'm going to write the answer down. So 2. Okay. Anyone have anything different?
32.
32.
32. Okay. Now, anyone have anything different? Okay, so those are the only 2 answers y'all are coming up with. All right. Well, the good news is one of them is right. Bad news is one of them is wrong. So this is where I'd normally ask the class to raise their hand, and let's see how many of them got it right. So let's see.
I'm probably the only one that got it wrong.
Not everyone's on video, so it's okay. But let's see. How about 2? Who got 2? Just say yes or raise your hand.
I got 2.
Yes.
Got 2.
Okay.
I got 2.
All right. How many of you got 32?
I got 32.
I got 30.
I got 32.
Okay, so it seems like about half, maybe more 32s than 2s. So somebody who got 2, You want to volunteer and explain how they got 2? Volunteer.
I used the multiplication because it was PEMDAS, so the M came first. But I'm starting to think it's whichever or came first.
So PEMDAS, you said PEMDAS. We haven't talked about this. This is this little, do we call this an acronym?
Yes.
I'm not sure. I'm not an English major, but I believe an acronym has to spell a real word.
It doesn't.
So like MAD, Mothers Against Drunk Driving, or something like that. That's spelled, well, MAD isn't really a word. What's a better example?
An acronym is just a string of letters that represent something that doesn't necessarily have to be a word.
It doesn't have to be a word?
No.
Okay, so, all right. So this would qualify as an acronym then? Okay.
Yes.
So PEMDAS is a thing to help us remember the order in which we do operations when we're doing mathematical computations. The P stands for what?
Parentheses.
Parentheses. E stands for exponent. M stands for
Multiplication.
and then D stands for division, and then add, and then subtract. Now, the reason we have an order of operations is purely because we all need to do it the same way so that we all get the same answer. I mean, if we're building a bridge and we have to do a computation, we can't have one engineer get 2 and the other one get 32, right? We have to agree upon something. So, okay, so who volunteered to tell me how they got 2 again? You said you did multiplication
first, yeah.
Because multiplication appears in the PEMDAS first. And so if we do that multiplication first, we get, it becomes 16 divided by 8. And then I see, yeah, 16 divided by 8 would be 2. Okay. So how about somebody who got 32? Do y'all want to explain why you got 32? Volunteers?
16 divided by 2 times 4, and then you multiply it by 4.
16 divided by 2 and then multiply by 4? Yes. So you actually did this first, which 16 divided by 2 would give you 8, and then you'd multiply times the 4, and yeah, that would give you 32. So who wants to argue their case?
I always thought you did multiplication before division, but I don't know.
So someone who got 32, you need to tell me why 32 you think it's right.
I got 32, and I did it that way because there's no parentheses. Usually when you do parentheses, you do that first. So in this case, I felt like if there was parentheses over the 2 times 4, then that's what you would do first, and then divided 16, whatever you get. But since there's none, I just straight did 16 divided by 2 times 4.
So are you telling me that this PEMDAS, this multiplication division, are you telling me that actually the order doesn't matter in those? Like it's not multiplication before division?
The order does matter.
It does.
Okay, so the correct answer, we're almost out of time. The correct answer is 32. Here's why it's 32. The reason it's 32 is because as good as PEMDAS is, it's very easy to leave out the most important detail of PEMDAS, which is that multiplication and division are grouped together and they're always done left to right. It's like when you read a book. If you have multiplication and division appearing together, multiplication does not outweigh division, and division doesn't outweigh multiplication. It's just whichever appears first as you move from left to right. So since we have division and multiplication, they're equal, I'm going to move from left to right. I'm going to do this first, 16 divided by 2. And that's going to give me the 8. Then I multiply times the 4, and then that gives me the 32. Addition and subtraction works the same way. It's always left to right. So it is very common to get the answer 2 here. This is why I'm doing this example, because it's very common for students to get 2. It's just not right. So please, PEMDAS, understand how the multiplication division work, and that it's not always multiplication before the division.
So it's multiplication before division only if there's like parentheses and exponents and stuff like that, or what?
Yeah, so like one way I could have made it happen to get 2 would have been this. Now I'm going to get 2 because the parentheses forces me to do the 2 times 4 first. And that would give me the 8. Then I do 16 divided by 8. But that's the only way I'm going to get 2. What's kind of cool is if you go to your calculator and you just type in 16 divided by 2 times 4 just all together in one line on your calculator and hit enter, you're going to get 32. And that's because your calculator actually knows to work from left to right. So it's built into the programming. Okay, so we are out of time. We're obviously going to be a little bit behind, but next time we'll probably move faster. So what I would expect for you to do tonight is on this schedule, before we meet again, I would expect that you at least complete the homework for pages 7 and 8. And see how it goes, and then we'll come in on Wednesday. We'll pick up with order of operations, linear equations. We'll be a little bit behind, but we'll see. We'll see. Okay. Also, one more thing. Our meeting for next time, I'm going to, every time we have a class, I'm going to email you, probably the morning of class, I'm going to email you the link to the Zoom session and the password. So every single time we're going to have a different link, a different number, and a password. And that's just so that we don't get Zoom bombed, okay, and have some crazy stuff happen. So
I thought that's why they did that new update to stop stuff like that.
yeah, maybe they did, but I'm being super cautious, you know. It hasn't happened to me, but I've had a few colleagues have it happen. Sounds fun, but I can't imagine the things that people put up. I mean, you know. Okay, any questions?
Nope.
I need to find a way to do attendance, and I'm not quite sure. Right now, we have.
Does that go toward our grade?
20. Well, I just need a way of making sure that people are coming, or at least being able to track it. So, you know, I have the video, at least the recording, so I know who was here. All right, I don't really have anything else. So, we good?
Yeah.
Okay,
Yeah, okay.
everyone have a great day.
Thank you.
All right, bye-bye.
Finally, I can eat my Tokyo treat.
All right, I'm going to end the session. Y'all have a good day.